Hello, everyone. We are going to start our brief review of radicals and just beginning with what is a radical and how can we simplify something. So a radical has this radical symbol here, and this means the nth root of a. The square root of 16, or the second root of 16, is what number times itself has a product of 16. Well, positive 4 times positive 4 is positive 16, and negative 4 times negative 4 is positive 16. What number times itself 3 times is 27? So we break that down. We have 9 times 3, 3 times 3. There's 1, 2, 3 threes, and so the answer would be 3. Now, I can't do negative 3 times negative 3 times negative 3 because 3 negatives end up to be a negative 27. So positive 3 is our only answer there. A reminder that even roots cannot have a negative under the radical sign. That's not real. We can't do anything with that right now. So how do we know? Because we saw, for example, the square root of 16 can have 4 or negative 4. How do I know which answer I'm supposed to give them? Well, check the front of the radical. In front of this 9, it's positive. And so they want the positive 3 for an answer. In front of this 25, it's a negative. And so they want negative 5 as an answer. Let's try a couple. Square root of 64. Square root of 64 is 8. And because of the negative in front, we would write an answer of negative 8. The square root of 81 is 9. In front of here, there is no negative sign, so they want the positive answer, positive 9. The square root of 9/49. Well, we can rewrite this as the square root of 9 over the square root of 49. The square root of 9 is 3. The square root of 49 is 7. And in front of here is positive, so positive 3/7 would be the answer we give. This last example, we have the square root of 100, the square root of 36. The square root of 100 is 10. The square root of 36 is 6. Well, remember, this is a fraction, and 10 over 6 can be reduced by a factor of 2 to make that 5/3 for a final answer. So what happens if it's a non-perfect square root? There's not exactly one number that makes 25 is 5. So something like that. Well, we're going to try something like a factor tree and see what we can pull out from the numbers that we have. Radicals that cannot be simplified are called prime because they have prime numbers that can't be broken down and there aren't any pairs there. 72. Well, let's see. I know 72 is 9 times 8. You know, 9 is 3 times 3, 8 is 4 times 2, and 4 is 2 times 2. Well, this is the second root, the square root or the second root. Second is 2, so that means there has to be a pair of them in order for them to be able to come out from under the radical. This 2 here does not have a partner, so it has to stay inside the radical. So the 3 comes out, the 2 comes out, this is multiplication, and then this 2 gets stuck under the radical. 3 times 2 is 6, so 6 square root of 2 is a simplified form of the square root of 72. 28. 28 is 7 times 4. 7 I can't break down, but 4 I can break down to 2 times 2. I have a pair of 2's here because, again, this is a second root or a square root. but I don't have a partner for the 7. So the 2's come outside the radical, and the 7 gets stuck inside. I have nothing to multiply there, and so that would be the final answer. The third root is 16. So if the square roots, you had to have 2 or pairs, then for third roots, you have to have triplets for them to come out. 16, I know, is 4 times 4. 4 is 2 times 2, and 2 times 2. Remember, I need a group of 3 for them to be able to come out from under the radical. Here's a group of 3 2's, and that one gets stuck at home. So the 3 2's, the group goes outside. We have our third root, and the 2 that was an oddball stays home. That's what we have to multiply. 108. Well, those are even numbers, so I know I can divide by 2, and that would give me 54. 54 is 9 times 6. 6 is 2 times 3. 9 is 3 times 3. So again, I need a group of 3. So here's a group of 3 3's, but I only have 2 2's. So those 2 2's have to stay home. So the 3 comes outside. I have my third root. And then the 2 2's we underline here go underneath. We multiply those together to get 4. And so 3 times the third root of 4 would be our final answer. This last example, the square root of 17. Well, 17 is just 17 times 1. That's it. It's a prime number. I clearly don't have any pairs there for the second root to pull out. And so we would call this prime because we cannot reduce it. That's it for our notes for today. Thank you for joining me. Have a great rest of your day.